Okay, these are the 9.3 notes, double angle, half angle, and reduction formulas. This is page 3. So example 4, exercise 4, whatever we want to call the EX. We're going to use the double angle formulas to confirm an identity. So, as with any other identities, we want to start with the side that looks like it's going to be the most complex. So I'm going to go ahead and start with the right-hand side. If for no other reason, then I have something automatically that I can do without having to worry too much about whether or not it's the exact right thing to do. So I'm going to multiply these out. We get sine squared x plus sine x cosine x plus cosine x sine x plus cosine times cosine, so cosine squared x. I'm going to go ahead and regroup this, so I have sine x squared, sine squared x, plus cosine squared x. And then the sine x, cosine x, it doesn't really matter what order we multiply them in. They're the exact same, and I have two of them. So I'm going to write that as 2 times sine x cosine x. This first piece we recognize as the Pythagorean identity, that's 1. This second piece, 2 sine x cosine x, well, that's just another way to write sine 2x. So we are done. 1 plus 2 sine 2x. I will give you advanced warning. Whole lot of space on these top two problems. Not quite enough space on the bottom two, so we will make it work. So B. This time I'm going to go ahead and start with the left-hand side because that is a difference of two squares. So I'm going to factor this as cosine squared theta minus sine squared theta times cosine squared theta plus sine squared theta. This second set of parentheses is 1. The first set of parentheses, cosine squared theta minus sine squared theta, that was our very first version of cosine 2 theta. So this one's done. A whole lot easier than it looked. Okay. Down at the bottom here, we can use these formulas backwards. Okay. We can solve for sine squared theta. Solve for, anyway, we're just going to use the formulas as is. I'm sorry, I've got a dog over here breathing heavy. So A, cosine to the 4th x. So cosine squared theta up above looks like this. Cosine squared theta equals 1 plus cosine 2 theta all over 2. So I can do that and use that to rewrite cosine to the 4th as cosine squared x squared. So I'm going to take care of those inside parentheses first. Cosine squared x looks like 1 plus cosine 2x all over 2. We're going to square that. When I square that, you know what? Let's write it this way. 1/2 plus cosine. No, we don't want to do that. That's not what I did in my notes. Back that truck up. We're just going to square the numerator and square the denominator separately. So my numerator looks like 1 plus, I have cosine 2x plus cosine 2x, so I have 2 cosine 2x. And then I have cosine 2x squared. So cosine squared 2x. This is all over 4. I don't need this parenthesis. And so the first part we're golden on, this is 1/4 plus 2/4 cosine 2x. Neither of those have a power bigger than 1, so that's good. But I have this cosine squared 2x, and so I'm going to use that reduction formula again. And I'm going to write cosine squared 2x as 1 plus cosine. Well, I've got 2 times 2x, so that's going to be a 4x. That's all over 2. It's still all over 4 from before. You know what I mean about running out of space here? 1/4 plus 1/2 times the cosine of 2x. Plus, I have 1 over 2 over 4, so 1/8. Plus 1/8 times the cosine of 4x. 1/4 plus 1/8, so 2/8 plus 1/8, we get 3/8. Plus 1/2 cosine of 2x plus 1/8 cosine of 4x. Notice we no longer have any powers greater than 1. So that one's done. Up to B. Cosine squared 3x minus sine squared 3x. So I could use the reduction formulas. The one thing that I do notice here, though, if I go back to my double angle formulas, cosine 2 theta is cosine squared theta minus sine squared theta. If I call theta 3x, then I have the right-hand side. I have cosine squared 3x minus sine squared 3x, which means this becomes cosine of 2 times 3x. This is the cosine of 6x. Okay, so it's not always a reduction formula. You are looking for the patterns. And so start thinking about that when you see that cosine squared minus sine squared. And that is it for page 3.